Now the question comes that while naming the compounds, what rule has to be followed, right? So these rules actually serve an important use, because if you are not well versed with the rules, you won't be able to attempt an IUPAC. That means you won't be able to write a correct name, right? So just look at the board carefully. First rule is that to select the parent chain. Right. There are two limitations, or you can say there are two important points which has to be considered while selecting a parent chain. One is that the chain should be continuous. That means there should not be any break in mid. The chain should be continuous, right? And it should have maximum number of carbon atoms. It should have maximum number of carbon atoms. So these are the two you can say the important points which we have to consider while selecting the parent chain, right? So that means the first step is that we'll select the parent chain, and while selecting we'll take 2 points into the consideration. One, the chain is going to be continuous, and the second is that it should possess the maximum number of carbon atoms, right? Suppose I'm stating an example for you. Suppose we have a compound like this. Right. So I'll write 2-3 examples, then we'll see the difference also that exists between them. So this is again another compound. These are all, you know, I think that they are organic compounds, because IUPAC is written for the the organic compounds, right? Right. So it's like this. So it's like this. So the first step is that we have to select the parent chain, right? So just look at the board how we are going to do that. So that means the 2 points, as I told you, are very important. The chain should not break in the mid, and it should possess maximum number of carbon atoms. So let's check in this. So if I select this chain, how many carbon atoms I am getting in? 1, 2, 3, 4, 5 and 6. Right. Do I have some other option? Yes, I have. I can select the chain like this. I'm just showing it with a different figure so that you can just differentiate between these parent chains. So how many carbon atoms are here in this case now? 1. So first I'll write side by side. When we select the square one, the carbon atoms are 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Right. But when I select this chain, how many carbon atoms are included? 1, 2, 3, 4 and 5, and I have an option that I may select this chain as well, right? So how many carbon atoms are enclosed in this case? 1, 2, 3 and 4. So there is no other option of selecting the parent chain. There are only 3 possible parent chain. One is this one, the other is this one, and the third is this one, right? So how many carbon atoms, or you can say in which chain you have got the maximum number of carbon atoms? Obviously in the 6th one. So that means in selecting this chain, which you can say the chain is going to act as a parent chain. So it is this one, the straight chain, the square one. That means the chain which consists of the 6th carbon atom is considered as a parent chain. So this is the correct one. That means this one. This is a parent chain because it has got maximum number of carbon atoms. And how many maximum? 6 carbon atoms. So let us see in this case, in this example, how many carbon atoms? We have only one option, that means this straight chain, right? We don't have any other option. That means our parent chain is going to be this one, and it comprises of how many carbon atoms? 1, 2, 3, 4 and 5. So obviously this chain is going to be a parent chain because there is no other option of selecting a parent chain. Now let us see in this case how many carbon atoms are here, or how many options do we have for selecting a parent chain. It can be this, right? It can be this, it can be this. So let us see how many carbon atoms we are getting in. When I was selecting a straight chain, it included 1, 2, 3, 4 carbon atoms, right? It was the straight one. And when I selected this chain, how many carbon atoms were included? 1, 2, 3, 4 and 5. And when I selected this chain, then 1, 2, 3 and 4. So that means 4, 4 and 5. So which chain will be preferred? Obviously the 5 one. And which is that? This is this one. So that means the parent chain which is selected is this one, because it comprises of maximum number of the carbon atoms, and we know that while selecting a parent chain we need a chain which should not break in mid, and it should also possess the maximum number of carbon atoms. So this is, we have this parent chain, right. Similarly in this case we get to have the parent chain, this one we can have, right. So how many carbon atoms are here? 1, 2, 3, 4, 5. And I have an option for selecting this one as well, right. So how many carbon atoms? 1, 2, 3, 4, 5, 6. So obviously this chain is preferred over this straight chain, right. And the other option what I have is, I can select this chain as well, this one. I think it's clear to you which chain I am selecting. So how many carbons are here? 1, 2, 3, 4, 5, 6. Again the 6, right. And I can have this option as well. So how many carbon atoms? 1, 2, 3, 4, 5, 6. Again 6. So in this case, in many of the cases we are just having the same number of carbon atoms, 6. So what chain you are going to select in this case? We'll select that chain, like again I am telling you, write in your notebook along with that if in case we have different parent chains comprising of the same carbon atoms, then preference is given to that chain which is highly branched. That means which has got lot of substituents around. We prefer that chain. Like as I told you, we are getting 3 options for the parent chain. So out of them we will be selecting that parent chain which is maximum alkylated. What do you mean by maximum alkylated? It means which has got a maximum number of like I said, alkylated, we know alkyl group is a substituent, like, but in a general language what I will be telling you is that the chain, that chain will be preferred which has got the maximum substituents, or you can say which has got the maximum branches. And if the substituent is alkyl group, so then I will say that with the chain which is maximum alkylated, right. So these are the rules that how to select the parent chain. I think it's clear to you. So while selecting the parent chain, there is we need to have a big chain, right. That means the chain which comprises of maximum number of carbon atoms, and if in case we have more than one option, we look for a parent chain which is maximum substituted, which has the maximum number of substituents around, right. And the second important point, the chain must not break. It's not like that you select some carbon atoms from here and some from this side. It's not like that. You have to select the chain whether it is in this form, whether it is straight, whether it isn't, but it should have the continuous carbon atom. There should be no break in the mid, right. So this is the first rule, that is the selection of the parent chain, right. Now I'll be explaining you the second rule. So after just selection of the parent chain, what we'll be doing, the second step is that we have to number the carbon atoms present in a chain, right. So I'll just write it here. So what is the second step? Second step is to number the carbon atoms in a chain. It is a very important step, right. If you fail to do the numbering properly, that means you are going to get an incorrect answer. So just look at for the rules that how you have to opt those rules while giving the numbers to the carbon atoms of the parent chain, right. So how you number? Suppose I'll just explain this rule with an example. If we got the parent chain of this, so numbering can, what do you get to see in this? We get to see nothing, there are no substituents, right. Everything what is there in the organic compound is included in a parent chain. That means it has no substituents, no prefix is going to be there, right. So whether you number it from this side or this side doesn't make a difference, right. So I can number it like 1, 2, 3, 4, 5 starting from here. I can number it 1, 2, 3, 4, 5 either starting from this side. So we can number it any way, by both of the ways we can do that. It's correct because it has not got any substituent, right. So if the first point is clear in your mind, if there is no substituent, if there are the atoms, everything is included in a parent chain, numbering can be done from any side. The second what I want to explain you, the case, an example in which you have to consider the number, or you have to do the numbering properly. Suppose this is a parent chain, right. So do you get to see something extra from the parent chain? Yes, we get to see this carbon atom extra from the parent chain, right. So that means this carbon is going to act as a substituent. We know that anything which is left after the parent chain is considered as substituent, whether it is left above or below or this side or that side doesn't make a difference. Anything which is left, you can say after the pair selection of the parent chain, the group of atom or an atom which is left behind is said to be a substituent, right? So that means in this case numbering plays an important role. You cannot number according to your wish or from either side, you cannot do that. We have to follow a certain rule, and rule is that while numbering the carbon atom which has a substituent, right? First of all, it should be clear substituent is not at all numbered, right? It has the number, like suppose it is attached to this carbon atom of the parent chain. The number of this carbon atom is a number of this substituent. You are not going to number the substituent, right? Substituent number will be the same number with which it is attached to the, you can say, the carbon atom of the parent chain, right? So that means, and the rule is that while you are numbering the carbon atoms, you can say the carbon which carries the substituent should get the least number. So how we will use this rule, just see to it. If I have an option of numbering from this side, right, I have an option of numbering from this side. These are the two methods by which I can number, you know that. But when I number from this side, so what number does the substituent is getting? 1, 2 and 3. We know that the number of this carbon will be the number of the substituent. That means in this case the substituent is getting 3 number, right? And if I do from this side, what number the substituent is getting? 1, 2, 3, 4. The 4 number. So that means if we can number it from the either way, right? But the preference is given to that numbering in which the substituent gets the lowest number. I may repeat, that's not the substituent, it is actually the carbon atom to which the substituent is attached, right? So that means which numbering is going to be correct? Yes, this one, the above one. So it is given 3 number, right? So that means the substituent number should get the carbon atom which carries the substituent should get the lowest number. That is an important rule. Now, see one more example. Because if I'll state the points just in the way, you won't be able to know them properly. But if I'll state with an example, it will directly cling in your mind and it will get stored there. So that is why I'm stating a points with an examples, right? Suppose I have this thing, right? So I have this parent chain, right? So how I can number it? I can number it from this side also, I can number it from that side also. So just do it, let's do it. 1, 2, 3, 4 and 5 and 6, right? And if I do from the bottom, or you can say if I do from that side, it is 1, 2, 3, 4, 5 and 6, right? So what are the number of the substituents? You know that the substituents should get the lowest number. So let us see that the case in which I have written the numbers with the black. So let's see that what number the substituents are getting. So in this, to the position 2 carbon atom the substituent is attached, and with the 4 also the substituent is attached, means the position is 2 and 4, right? But if I look at the numbering which I did with the red pen, then they are getting 3 and it is 5. So that means I told you that if there are substituent present, then we have to number the carbon atom with the lowest number, right? But what rule you will apply if there are more than substituents, more than one substituent is present? As you get to see in this example, we have got 2 substituents. So that means which substituent will get the lowest number? So what we will be doing? We will be following the lowest set of locant rule. There is a rule that states the lowest set of locants. Write in your copy, it is lowest set of locants. So how you do that? What is the rule, or exactly what I mean by saying it? So it is like that, like I told you that with the black one we get to see 2 positions, right? And with the red one which I wrote, we get to see these positions. So lowest set of locant just says that first match the position, first match the first position, right? See, if I number it from this way, the substituent is getting 2 number, and in this case it is getting 3 number. So he says, this rule actually states that out of them, which has the lowest number is preferred. As you can see that out of 2 and 3, 2 is smaller, so that means this kind of numbering is the correct one. That means numbering is done with this method. That means in which the substituent are getting the lowest number. As you can see, in the first case, one substituent is getting 2 number and the one substituent is getting 4 number. But in the other case, the one substituent is getting the 3 number and the other one is getting 5. So obviously, in which set you are the substituents are getting lowest numbers? Obviously, in the first one. So that is why the numbering is done in this method, the above one, right? So I think it's clear that how you have to number the atoms, or you can say, sorry, the substituents, right? Now, one more example is just striking in my mind. This we consider by considering if there are more than one substituents, right? So if there are substituents like this, right? If I have substituent this like this, because here we were just considering the substituents, we were not considering this rule that whether the substituents are same or whether the substituents are different. So if the substituents are same, then also it matters a lot, and if the substituents are different, then also it matters a lot. So just look at the board how it matters. So we can just look at the board that obviously this is going to be a parent chain, right? So there we have got two substituents, one is this and one is this, right? That means that both the substituents should get the lowest number. You know that the lowest set of Locant rule, you know that if we'll number it from this side, we are getting 2 and 4, right? If I number from that side 1, 2, 3, 4 and 5, so I am getting 2 and 4 again. So now the question comes, which side will be preferred, right? Because when I am numbering from this side, I am getting 2 and 4, right? And if I am numbering from that side, then also I am getting 2 and 4. But the question comes, which you can say the type of numbering is going to be preferred. So just keep in mind, write in your copies that if in case the two substituents are same, like for example, if it was, it is C2H5, but if it was CH3, then it hardly make a difference whether you number from this side or that side. So either of this you can use, right? But if there are two substituents which are different from each other, but we are getting this thing, we cannot use the lowest set of Locant rule because the two you can say the position of Locants are same. Then you use the alphabetical order. And what is that? You get to see this is a methyl group and this is a ethyl group. And as you can easily recall, A, B, C, D and all, and which letter comes first? So obviously E comes first. That means ethyl group should get the lowest number. So that means which side of numbering will be preferred? That side of numbering will be preferred in which the ethyl group is going to get the 2 number, right? So that means this one, 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4 and 5. Sorry, I missed some number. 1, it is 2, it is 3, this 4 and this is 5. That means we specify the position in which the ethyl group gets the 2 number and the methyl gets the 4 number, right? So this is how I think you are clear with the numbering, that how you have to number. Again I am repeating in a short span, just look at the board. If you get to see everything included in the parent chain, hardly make a difference that you number from this side or that side, right? But if you get to see some substituent attached, something left after the parent chain, then you have to use the rule that the substituent should get the lowest number. That means the carbon atom which bears the substituent should get the lowest number. Now the question comes, if more than one substituent are present, then we use lowest set of Locant. Like we number from this side also, we number from that side also, and we just compare the first positions, which is smaller, that is obeyed. And if in case the first position or you can say seems to be same, like if it is 2, 2, then we just look for the second position. And similarly, if out of those two second position, which has the lowest number is just obeyed, right? Similarly, if I told you that if we cannot use lowest set of Locant rule, that means from both the sides the position are just coming out to be same, then what we are going to do, if the groups are same, then we can use either of. But it matters a lot if the groups are different, then we number in the alphabetical order. That means the substituent which comes, whose alphabet comes first in the alphabetical order is given the lowest number and the other one is given a bigger number, right? So this is how the numbering of carbon atom in a chain is done, right? Now this is the second rule. 2 rules you have already done. One is the numbering of the parent chain, selection of a parent chain, and the second is numbering of a parent chain. So we'll be taking up the third point, that how you can say how we have